Hello everyone. In this session, we are going to solve this additional practice question paper that CBSE has released. Now, this practice paper is entirely based on your exam pattern. Okay, so you would see exactly you have 5 sections A, B, C, D, E, and all the questions are in the same pattern that are going to appear in your board exams, in your final exams. So section A has all the MCQs, 18 MCQs, and 2 assertion reason, total 20 questions. Similarly, section B has 5 very short answer questions of 2 marks each and so on. I'll share the link to this question paper in the description. You can go and download from there. Okay. So it has released these additional practice papers not just for mathematics but for sciences and language subjects as well. So go download and attempt it at least once. Okay. In today's session, we're going to look at the solution to this question paper. Let's get started. Okay. So we are going to get started with section A, where you'll find all the multiple choice questions, or you can even say 1 mark questions. Okay. So here are the options. The options can also be seen. So yeah, we'll get started with question number 1. Which of the following could be the graph of the polynomial x minus 1 whole square into x plus 2? Now, this, what type of a polynomial is this? Is this a quadratic polynomial or a cubic polynomial or a linear polynomial? We can see it's a cubic polynomial. How did I know that? 2 powers of x comes from this term and 1 comes from this term. So if you multiply, you are eventually going to get one term where x will be raised to the power 3. So that's why it's a cubic polynomial. Now remember, how does a cubic polynomial look like? How many cusps would you see in a cubic polynomial? If you do not remember, try coming from quadratic polynomials. A quadratic polynomial looks like a parabola, one cusp. This is what we are calling it as cusp. So one cusp in a quadratic polynomial. In a cubic polynomial, we're going to have 2 cusps. So it would be something like this. Okay. Sometimes it may intersect the x-axis at 3 points exactly, or sometimes just 1 point, something like this. Okay, this is also a cubic equation. This also represents a cubic polynomial. So let's see what are the options. Okay, and then okay, this one is definitely not a cubic polynomial, it's a quadratic polynomial. It's the graph of a quadratic polynomial. The second one, well, it's a cubic polynomial. Okay, this can be the answer, but let's see the other options. Okay, well, this also has 2 cusps. Again, it can be a cubic polynomial. What about the last option? Again, 2 cusps, so cubic polynomial. So just this information is not going to help us figure out the answer. Let's look at the zeros of this polynomial. Okay, so first thing we figured out, at least we could eliminate the first option. That's a quadratic equation, everyone knows. Option A is definitely not the answer, that we know. Now let's look at the zeros of this cubic polynomial. We don't need to find all the zeros, just a few would help us. Let's see what we can find out. So this cubic polynomial will become 0 if either of these terms, if either this or this, if any of these 2 terms become 0, the entire polynomial will become 0. I hope everyone understands that. When will x minus 1 become 0? When x is equal to 1. So x equal to 1 is definitely a 0. So when you are looking at the graph of this polynomial, you will see this polynomial cuts the x-axis at this point. Okay. What about the second zero? The second zero is x equal to minus 2. Let's say this becomes 0. This becomes 0, or x plus 2 becomes 0. So x equal to minus 2. This is where this would cut. Okay, while we are there, let's do one more analysis so that we can directly get the answer. Here's the analysis. Two of its zeros are actually the same. So this will give you two zeros. And both the zeros are actually the same. So x equal to 1 and x equal to 1. And this will give you the third zero, x equal to minus 2. So from here, we can even draw the graph, you see. We have the x and y axis. At x equal to minus 2, it cuts, this polynomial will cut the x-axis. So here, this is x equal to minus 2. And at x equal to 1, there are two zeros. How is it possible to have two zeros at one point? If we have something like this, this means that both the zeros are here at one point. Let's see. So this is our answer, okay? This is our answer. This is x-axis, this is y-axis. Let's see which of the options matches the answer. It's not this one, because here two zeros are at minus 2. That's not our graph. Let's look at our graph. It's like this. So option B is not correct. Option C looks correct. Let's check out option D also. Well, the roots are all different, okay? Minus 1 and 2, which is not the correct one. So here, this is your correct answer. Option number C, okay? Let's move on now to question number 2. The lines K1, K2 and K3 represent three different equations as shown in the graph below. Let's look at the graph below. Okay, K1, K2 and K3. These are the three lines. Alright, what else? The solutions of the equations represented by the lines K1 and K3 is given to us. X equal to 3 and y equal to 0. While the solution to the equation represented by K2 and K3 is x equal to 4 and y equal to 1. Okay, let's plot all these things in the given graph. So the second line says the solution of the equation represented by K1 and K3. So this is K1, this is K3. Its solution would be this point, right? Solution of linear equations, a pair of linear equations would be where those two lines cut each other or intersect. So this point is given in the question as 3, 0. 3, 0. Also, there's some more information given. The solution of the equation K2 and K3, that's 4, 1. K2 and K3, let's look at K2 and K3. This is K2 and this is K3. So their solution would be this. This solution is 4, 1, right? 4, 1. What do we have to find out? Which of these equations or which of these is the equation of the line K3? Okay, we have to find out the equation of K3 or identify the equation of K3. See, if you look at the point K3, both these points, do they lie on the line K3 or not? Yes or no? Both these points lie on that line. With this information, we will be able to create the equation of K3. Okay, there are many ways to solve this. What you can do is, you have these 2 points, just plug and play. Keep plugging these points in all the equations, and you will be able to discard some of the equations, keep some, then plug in the second point in the other equation. How to plug in? Let's check out. X minus y equal to 3. So 3 minus 0 equal to 3. I've taken x from here, y from here. Okay, x and y have been taken from here. Okay, so this satisfies the first. While we are at it, let's try the other point also. 4 comma 1, does this satisfy? So 4 minus 1 is also equal to 3. Yes, LHS equal to RHS. This is your answer. I did not need to check the other options, okay, because there can be only one answer which satisfies both the lines, both the points, okay, which has both these as the solution. So there can be only one correct answer. But just for the sake of it, let's try the other options. 3 comma 0. So 3 minus 0, is it equal to minus 3? No. 3 comma 0 is not equal to minus 3. So you can discard this option right away. You don't need to check the other point. Even if it is there, that's fine. One point is there, but it's not the one that we want. Let's look at the third. X plus y equal to 3. So 3 plus 0 equal to 3. Okay, this one is satisfying the first point. Let me call this A. Let me call this point as B. And what about the second one? 4 and 1. So let's see. 4 plus 1 equal to 3. Is it? No. So we can discard option C also. Let's look at option D. X plus y equal to 1. So we have 3 plus 0 equal to 1. Is it? No. 3 plus 0 is not 1. So this option is also not correct. And we are done with second question. So let's look at question number 3. What are the roots of this equation? So we have a quadratic equation, 3x square minus 6x equal to 0. And they're asking what are the roots of this equation. Okay. Let's see if we can take something common. X can be taken common. Then we have 3x minus 6. In fact, we could have taken 3x common also. But yeah, both work. Okay. Now, this will give you two roots. Either x can be 0 or this term can be 0. That will make our quadratic equation 0. So if 3x minus 6 is 0, that means x is equal to 6 upon 3, which is 2, right? So x equal to 2 and x equal to 0, these are the two roots of the equation. So 0 and 2, that's option number D. Alright, let's move on to the next question now. The coordinates of the center of the circle O and a point on the circle N are shown in the figure below. Let's look at the diagram. Okay, the coordinates of O and N are given to us, and they're asking what is the radius of this circle. So the radius of this circle is essentially this. We have 2 points. We have to find the distance between them. You know the distance formula from coordinate geometry. Just apply that. Okay, so the distance is, let me quickly write that. x2 minus x1 whole square plus y2 minus y1 whole square. Now, this formula is written in different books and different forms. It can also be written as x1 minus x2 whole square plus y1 minus y2 whole square. So whichever you use, just be consistent. I'll call this as x1 comma y1, this as x2 comma y2. And if I use this, so x1 minus x2, that means x2 minus x1, x2 minus x1. So minus 2.4 plus 4, because minus of minus 4 becomes plus 4, plus y2 minus y1. That's 1.8 minus 3. Do not worry that this quantity is turning out to be a negative number. Doesn't matter, because if you square a negative number, you're going to get a positive number. So we are safe. This is equal to minus 2.4 plus 4, that's 1.6 whole square, of course. You forgot that whole square there. 1.6 whole square plus then 3 minus 1.8, or 1.8 minus 3, that's 1.2 minus 1.2's whole square. Okay, let's write it like that. You calculate 2.56, 1.44, you add them up, find the radius. So that's 3, actually 4.00. Yeah, so that will give you plus or minus 2. Minus 2 can't be the radius, length cannot be negative, so we choose plus 2. The radius is 2 units. That's your answer. Alright, let's move on to the next question. Question number 5. Triangle PQR is shown below. ST is drawn such that angle PRQ, that means this angle, is same as angle STQ, that means this angle. Okay, so if this angle and this angle is same, we can see that this angle is common to both the triangles PQR and QST. If two angles are the same in two triangles, the third angle will also be the same. So the third angle, that means this angle, will be equal to this angle. If all the three angles of two different triangles are the same, that means you can write triangle PRQ is similar to triangle. Remember the order is important. Okay, if we selected P first, we should select S first, because these two angles are equal, not because they are on the same base, not because of that, but because these two angles are the same. So S, then second I wrote R, so T, and finally I wrote Q. So triangle PRQ is similar to triangle STQ. With this, we know the relation between their sides. We have to find, see, if ST divides QR in the ratio 2:3, so something else is given to us, that if this is 2, then this is 3. So yeah, 2:3, so we'll just write 2:3 instead. This is 2:3. Okay, this is given to us, and the question is asking us the length ST. This length. What is this length? Okay, so we can see ST upon PR would be equal to QT upon QR or RQ. This is the relation which will help us find the length of ST. So PR, we know 20 centimeters. Let's substitute the values now. ST upon 20 is equal to QT. Okay, QT upon QR. QT upon, so ST divides QR in this ratio, right? So what's given to us is this. Given to us is that QT upon TR is 2:3. This is what is given to us. You can use componendo and dividendo or simple ratios to find QT upon QR from here. Okay, QR, if you see, it's QT plus TR. So it's 2 by 2 plus 3. That's going to give you 2 by 5. So this is 2 by 5. Okay, this part is very important. This is what the examiner is trying to test you, whether you pay attention or not. So many students are going to do this mistake. They are going to write 2 upon 3 instead of 2 upon 5. This is not correct. Okay, so if you have this equation, now you can find the value of ST, and that value would be 2 into 20 upon 5. That's 8 centimeters. It's option number